So for my project, I decided to do a wireless phone charger. So kind of the main problem I was trying to address with the charger is basically to create something that obviously won't need an outlet and will be able to be transported with the customer wherever they need to go. Basically the main goal here is to make a charger for someone who's always on the move, doesn't always have access to a wall outlet that they can plug into, and are constantly on their phone and constantly need charged pretty much daily. So the conceptual outline for the project, there's two components to it. The first component is a transmitter circuit, and the second component is a receiving circuit. So for the transmitter circuit, starts with a power source, obviously coming from a battery or power supply, which needs roughly 12 to 9 volts. And then there's a switching circuit that alternates the current coming from that power supply by switching some sort of transistor on and off. And then that alternating current goes to a coil, the transmitter coil, and that coil transmits a magnetic flux with that current to a receiving coil. And then the receiving coil, part of the receiving circuit, receives that magnetic flux, and from that a voltage is created. That voltage is then rectified and regulated, basically meaning it regulates the voltage just enough for the phone to take, also with the current. And then the phone battery is obviously at the end, and it charges based on how much voltage and how much current it gets from that regulator. So the basic design process for the project, I started off with just creating schematics, as you can see in the top two pictures there, for the transmitter and receiver circuit. So I would calculate components. With those components, I put them into circuit schematics, simulate the schematics, and then basically change things if needed to be based on the simulations. And then the middle two pictures there are the schematics for a printed circuit board or a PCB, and then the bottom two pictures are the actual boards for the PCBs right before they were ordered. I decided to do a PCB for both circuits just because it's much easier to assemble components with PCBs. There's a lot less errors when you use printed circuit boards instead of breadboards. So basically, the final result of the project, after I assembled everything together onto the PCBs, basically the boards weren't able to generate any power whatsoever. I hooked up to the output of the regulator to see what was coming out of it, and I wasn't getting anything. So there's basically a couple reasons for this. One, errors in the PCB design. It was one of my first times actually designing a PCB and ordering a PCB. So there were some mistakes on my part. Like one, I used soldering pads instead of holes for the capacitors and the resistors. You can see in the top two pictures there, the capacitors and resistors were basically soldered onto these tiny little pads, and I had to use a decent amount of soldering just to get them to sit still. So that could be a big reason why I wasn't generating anything. And then the coils on the wrong side of the board for one of the boards. I wanted to have the boards sit on top of each other, but they can't be if the coils are both on the top layers. As you can see in the bottom picture there, I had to put one upside down. And just overall, poor soldering job on my part because of the PCB errors.